Hey everyone, in this video we are going to explore a multi-agent or agentic workflows. This system that I developed can write multi-file full games on 1000 lines of code, which work really well, using on average about 10 agents at a time, but there's really no limit on how many files project you can make or how many agents that this can spring into being. Let me just show you some of the games it has coded, then I'll explain what this is all about. If, for example, was able to build this snake game, which is very difficult to build actually, and it is fully functional with predictive block where the blocks are going to fall. And this is close to 600 lines of code spanning over 8 files. And it has level increments, meaning the game will get speedier. Everything in the game actually works. So this is pretty spectacular. I do want to say that there's a difference between open-ended agents and restrictive agents. Restrictive agent systems. This is a restricted or semi-open agentic system. That's why I restricted it to pygame, building pygame, but by simply changing the system messages, you can actually implement this to your use case very easily. Let me show you the space shooter game that it has built. It's almost 800 lines of code, actually, which is not possible with a single output from an LLM, since the LLM's outputs are limited to 4,000 tokens, which equates to about, give or take, 400 lines of code. We can actually play this game with sound on and off, and with the sound off. So it is a leveling system, and it has actually upgrades that drop, and when you pick them up, your ship will either become speedier or your firing rate will increase. These larger enemies are difficult to defeat. You have to shoot them multiple times. So there's quite a lot going on. Like I said, this is 800 lines of code, which just simply is not possible in a single go, but it's very nice, actually. It works very well. I'm surprised. And it's actually made up of 8 files, totaling about 800 lines of code. By the way, the code files for the Agentic Game Maker will be available at my Patreon. Link will be in the description. Let's take a look at another game it had built, the checkers game. Right after that, we'll start how it works, and I'll explain it. So here's a checkers game, which we can play. As you can see, it works well. So this is a multi-file game that it was able to build. Let me quickly explain with a diagram what's going on, and then we'll also run the code and go over the code as well. So we have two planner agents which talk to one another and user specified n many times, and they come up with a game plan, which then we write to gameplan.xml. So each one of the agents that actually write these files, so each one of these files are written by a separate agent, which doesn't know what the other files are going to be. So as you can see, the difficulty in this, for example, the agent that ran main.py had no idea what the mini.py was going to be, except for what was described in the gameplan.xml. So that's why this multi-agent interaction, where a lot of the agents actually don't know the final outcome, being able to produce this complex game is pretty mind-boggling, actually. So after the two planner agents talk to one another, they create a game plan and they outline how many files they're going to be in our project. And then my script automatically spawns up many code writing agents, let's say in this case 5, and each of these is responsible for a file without knowing what the other agents are writing. And once the entire project is written, then we enter an error correcting phase where we execute the code, and an error correcting agent actually tries to modify any one of the files or multiple files at a time to fix the error. We repeat this a total of 10 times, and you can actually manually continue this process as well. But once the game is running properly, then we enter a user feedback phase where you get to play the game and then give feedback to the user feedback agent, and this agent will try to improve the game for you. So at any time, you can have 2 of planner agents, 4 or 5 coding agents, and an error correcting agent and a user feedback agent, all working in conjunction with one another to build multi-file full projects for you. So there is no limit to how many agents can spring into being, but usually speaking, on average, there's about 7 or 8 and they all coordinate without really knowing all the information that is available. For continuing, I do want to say that this implementation is restricted to building games in pygame, but like I said, you can change the system messages for agents to actually accommodate many use cases. So let's go ahead and run this and see what is happening. When we first run it, we're going to get a welcome message to agent game dev, and it warns you that this script will automatically execute code, and we have to say yes to it, that we understand it's going to be executing code. And then it wants us to describe a pygame that we want to create. Let's just say a game of Pong. Let's say AI versus user. And how many planning iterations do we want? Let's go ahead and say 2 for brevity. So now the agents are going to go through planning iterations. Now, currently, we're not seeing what they're talking about, but we can actually turn on print false to true, and we can actually see that. So we can actually read what they're saying to one another. Let's turn this to true and actually run this again. So again, I've selected a game of Pong, AI versus user. So now the first part of the planning has begun. We will first see the first agent give an outline, and the second agent actually is responsible for creating more of the structure of the game. So here is the first agent's plan, and then the second agent's plan is going to show up in blue. And at the final stage, we change the system message so that they finalize their plans. Usually it's good to let them talk, maybe for 3 or 4 iterations, but if you let them talk for many iterations, then they can actually kind of go off course and talk about some stuff that maybe you don't want, such as how long the game is going to be take to build. Anyway, now after the game plan has been created, we save it to the game plan .xml file. You can read more about it here. And then we start creating game files. Each one of the game files are created in parallel by a separate agent, which has no idea of what each one of these files are going to be. And after that, we run the game and we get an error message, and we do a total of 10 attempts to correct the errors. And then we can also continue beyond that. But I just thought user can select it. So correcting agents reasoning process and the corrections to different files, and we get to see which files were updated, in this case the game.py and main.py, and we still got another error. And we also keep track of which files were present in the error message, but I realized that sending all files to correct the error is actually the best way to go, for reasons maybe I'll dive into later. Now it seems like, yeah, they were able to create this game. But as you can see, the Pong game, the ball is not bouncing from the up and walls. And now the game is running without error. We enter the final phase of this agentic system where we can provide feedback. So I'm going to ask, make sure the ball is bouncing off of the top and the bottom walls. And now feedback agent is going to take in our feedback and going to reason about it and return corrected files. And we can actually iterate on many times if we want it. So here we go. So this is working, but the bouncing is not. Okay. Now I'm asking, the ball is not bouncing off the top and bottom walls. Please implement the math for it. And like I said, we can repeat this as many times as we like. I do want to say that our app currently has 6 files with a total of 260 lines of code so far. And it's very difficult to get a file system working, as in this case, for example, to manage multiple files, and their interaction is actually much more difficult than writing a single file project. Okay, now it had updated after another try, but now it actually is running into another error. So during the feedback phase, when the game is trying to execute, if you run into errors, it will automatically try to fix these errors too. So the error correcting agent will trigger. But now we have a game that actually is corrected itself, and now we can play it against the AI. So this took a few iterations, but imagining that we didn't give the planning agents too many iterations to plan, this is actually pretty good. And it is with 6 different files. So this is how it works in a nutshell. Now let's go on to review the code files. so we can understand how we can build something like this. So bear in mind that this is quite a complex 500 lines of code, but you will have learned a lot about agentic systems by the end of it. But just so you know, the code files will be available at my Patreon, and I am starting regular Ask Me Anything sessions at my Patreon for Architect Plus patrons. Link for that will be in the description as well. The requirements for this is Anthropic and pygame. Now, the sub-process uses whatever libraries that are installed in your environment. So if you change this to reflect your own use case, make sure the necessary libraries are installed. Otherwise, you'll get an error and you'll have to install them anyway. But just keep that in mind. I would like to take a moment to talk about the benefits of becoming a patron. As some of you may know, in the last year and a half, I've spent 3,000 hours, over 300 projects. As a patron, you will have access to all the code files so you can get inspiration and iterate quickly. Another benefit is that you'll have access to all my courses. And my most recent and most proud one, the 1000x Masterclass, teaching what I've learned on how to code fast and efficiently. Also the Streamlit course and the Fast API course. In my Patreon, I also have tiers in which you can connect with me one-on-one. Check those out as well. Actually, I forgot to mention that another requirement is the term color for colorful printing in the terminal. Let's actually begin at the end of this script in the main loop, which is the create game function. All the functions in this process is async because we are using some parallel processing. So we're taking a user input to describe the game that they're looking for. Iterations is how many planning iterations there's going to be. And then we call the plan project function to get a final plan. After that, we save it to XML file, and then we create async tasks for agent write file method functions to actually write each one of the files to file. And then after that, now that we have our project ready, we enter a while loop to actually continually execute the code and get feedback. If there is no errors, we start taking user feedback immediately and update game files with the feedback agent. Otherwise, we try to identify the errors and actually call the error correcting agent. And then this loop continually keeps running until the user decides to break it. So now that we've seen how the main loop runs, let's come back to the beginning of the file and start going over it one by one. So this is all our imports. The interesting import here is subprocess to execute the code. And this XML x3 element tree, this actually is going to parse the file structure from the XML string. That's how we are actually creating this game plan XML, since we are instructing Claude to return in between XML tags. So this print, we initialize our async Anthropic. We are importing async Anthropic from Anthropic so that we can call it in parallel for file generation. We pass in our API key. Here we are detecting it from an environment variable, but feel free to replace this with your key. We are printing a warning that the script will automatically execute code on your machine, which can be potentially dangerous. And then we ask user to confirm this by typing yes. And then our main files are always going to be written under this app folder. But at the start of every iteration, we actually remove that folder. So each time you run this file, your app folder will be removed. So if you have produced something you like, make sure to copy this. Now, if you have this app folder open in a command prompt somewhere or something like that, or have a file open within it, then it's asking you to close in a terminal, which have the app folder open. But if you also have the files open, close them so that this can and then rerun the script to properly remove the app folder. Then we have a function which is necessary for Anthropic. This is to add a separator message between consecutive user messages. Now, Anthropic's API doesn't accept consecutive user or assistant messages in a row. In this implementation, we never get consecutive assistant responses, but we do get consecutive user responses into the message list. So this convenient function actually just checks for that and inserts an assistant message with just 3 dots. So this is just something we have to deal with. Other than that, here we are defining our plan project function, which is the function for planner agents to discuss and plan the project. The first system message says you're a logical critical game design expert, and the second one is a logical critical Python architecture expert. Your role is to discuss and plan a critical and rigorous eye a pygame project based on user input. You can see how you can change this to accommodate different projects that you want this agentic system to execute for you. So we're not going to read all of it, but there were some important parts. For example, I did say that focus on game mechanics, structure, and overall design. Here, in this case, code organization, modularity, and best practices. I did mention make sure no files need. I'm saying make sure no files. I should have said maybe code files need external files. All assets must be generated within pygame. This is because when you're creating pygame, maybe it may want to use some PNG or something like that, or some sound files. We don't want that. We just want everything to be all inclusive so that we can actually automatically execute this. The critical objective is to keep the project structure simple while making no circular imports and broken imports to occur. And I also mentioned that no need to discuss timelines or Git commands because they can just get carried away with planning how long the project's going to take and start planning what they should do in the week one and stuff like that. But this was very important that the imports for each file to be properly configured, since planning the game plan.xml needs to include what each file needs to import and make sure that there are no circular imports. Now, we are trying to fix that in the error correction phase, but we are also trying to eliminate any errors from occurring, and we just pass into the system messages, the user input as well. And then we add a message to the first planning agent. Please plan a pygame project based on the following user input. Remember that the game should start with a main module in the main.py file. Now, this was another important aspect, and the reason why restricting these agents is important because this game can have many different file names. For example, the main.py is usually the choice to start an multi-file application, but this could have also been like start.py. But that's just the file name. But even within the file name, the main function that runs it can have multiple names. For example, it can be main loop or start, but we want it always to be main, both for the file name and for the function name. And also we want main to not take any arguments, so we can actually run the code properly. So that's why we are actually mentioning it here, and we are going to mention it in other parts of this code as well. So then we enter a loop for as many iterations that the user has defined. We print a message. And if we are in the final iteration range, which we should talk about at the end, but maybe we'll come back to this, okay? So this is going to take place at the final iteration. Let's actually talk about it now. So there's some code that is going to run, but when we're at the final stage of the iteration, then we want to append the system user message that says, this is the final iteration. Please provide your final game structure along with file structure you think is best for the game. Don't return any directories, but just the file names and descriptions, because we want all files to be within the app directory, not within any additional directories. Make sure to mention what imports are necessary for each file. This is very critical. Critical objective is to keep the project structure simple while making no circular imports or broken imports to occur. I guess there's a typo here, or a broken sentence actually, but it works. Ensure function and other method inputs are accurate as well as their return. So we also want to make sure in the game plan, like which methods we're going to have and what will be their inputs and what will they be returning. This becomes crucial when each agent is working independently on their own file, so they give a general idea of what functions or methods and what inputs they're taking and what they're returning. Remember that the game should start with a main module in the main.py file. We are again repeating that concern that the game starting file is main.py and the game starting function is main function, which doesn't take in any arguments. So we iterate this here. Now, at this point, we do want to make sure that message one, since we added a user message here, and we are adding another user message here, that we have to add a separator between those two. Then we just simply call on If we set the print response to true, we print it and then just append the messages to the appropriate agent's message list. And if it is final, the last message that it gets, the second agent gets, which is going to be the one responsible for returning the actual XML game plan. This is the final iteration. Please review the game design carefully and provide your final response in the following XML format. So we paste this here, but you can see it more clearly here. It starts with a game plan and then it continues with overview mechanics, along with the files, with a file for each file. As you can see, this just is a repeating process, along with the definition of the file, along with the necessary methods or functions that are in it. And we do instruct it to not return any additional directories, but just the file names and descriptions, along with simple descriptions of functions and methods, along with their inputs and returns. Anyway, so you can read this, but this is a very important message. This is the final message. And I'm not saying this is the best message. If you do download the code, feel free to improve on it. And at this point, we do need to add a separator in this juncture too, and now we get a response. So we keep getting these responses anyway, all throughout the iteration cycle, but only if it is final, we add these final messages to actually for them to gather their thoughts and provide the final plan. I would like to take a moment to talk about the benefits of becoming a patron. As some of you may know, in the last year and a half, I've spent 3,000 hours, over 300 projects as a patron. You will have access to all the code files so you can get inspiration and iterate quickly. Another benefit is that you'll have access to all my courses. And my most recent and most proud one, the 1000x Masterclass, teaching what I've learned on how to code fast and efficiently. Also the Streamlit course and the Fast API course. In my Patreon, I also have tiers in which you can connect with me one-on-one. Check those out as well. And at this point, we just use regex to extract the plan and return the XML contents. Now, the next one is to define the agent write file. I guess this is not the best name to give it, but this is actually going to take in the file name, file description, and game plan. And we're going to call this multiple times in parallel. So this is a very important agent. Each one of these agents are going to be responsible for each one of these files within our project. So the system messages that you're a Python game developer to write error-free code based on the overall project structure. Do not include any external media files, val.commented code. The game should start with a main module in the main.py file. Main shouldn't take any arguments. Again, we are reiterating here. And it's going to return the code in this XML code blocks. This is the system message, and here's the prompt. Create a Python file name, and we pass in the file name. For example, the ai.py, bol.py, config.py. With the following description, we pass the file description, but we also pass in the overall game plan. Remember, the game should start with a main module, so we are repeating crucial stuff at every juncture. We also ask it to return the full contents of the file, and then we make the call. We get it. We take the code by splitting the string, and then we just write it to the appropriate file name. Now, this parse file structure is important only when we receive the XML string to actually parse it and actually write it to the game plan.xml. Now, next is the run game, which is going to be responsible for running the game that has been completed to check for errors. We're going to print some information, and then we're going to initialize two strings, full output and full error. We're going to run it with sub process, and we're going to keep track of both the std out and a std error. And we're going to append it because when you're running the pygame, you can get runtime errors plus terminal errors. So we're trying to keep track of both. So essentially, while true, we try to keep track of output error and the regular error. For example, the game may not you may get an error during the launch of the game, or you may get an error when trying to perform an action because maybe the code is broken. So we're trying to capture all of it and append it, and at the end of the day, return it right here. We keep adding the std out and std error to full output and full error, and including the error summary and return the error summary. And otherwise, sometimes we're not going to run into any errors. Then we say game completed successfully. Then we return none. Now, create game again is relooked. Is going to be the main loop. We specify next attempt. I'm sorry, actually, this is not the main loop, but this is the loop where actually we create and run the game and collect error messages. So we're going to try to do that up to 10, but we are also going to allow user to continue if they want to. After that, we're going to enter an infinite loop, and we're going to run the game, and we're going to get an error summary. And if the error summary is not, then we're going to say game ran successfully, and we're going to take in user input. And along with that, we're going to pass on to the update game files, which we're going to actually look into it. This is the one that is responsible for making a call to the feedback agent. And we print the count lines of code. We print how many lines of code that are actually present in our entire project. Now, otherwise, we print the errors detected, and then we try to attempt as many times as allowed, fix the game files, and print the count lines of code after each iteration. And when all the errors are fixed, they are fixed successfully. Otherwise, fail to fix all errors. After max tries, then we ask the user if they actually want to continue. So this actually can continue beyond the max attempts, but only with user consent. Now here's the fix game files function to fix errors in the game files. This is going to print attempting the fix error, and it's going to actually find all the files in the error messages. So my original thought was that I only wanted to send for error correction the files that were present in the error message, but that just wasn't the correct solution. Because sometimes main.py file, for example, would throw an error about config.py not having, like, let's say, screen height. Config.py wouldn't be present in the error because config.py is not really associated with that error. So at the end of the day, I do actually extract all the error file names, but in the end, actually, I create a dictionary and go over all the files that are in app and actually essentially have all the file names and their contents in this dictionary and send each time for error correction when we are making the API call. But if you do have error file names, we still print them. But when we are sending, we do send all the files for error correction, and we just print them for information purposes. And here is the system message for the error correcting agent. Your task is to fix error in the pygame project, analyze the error. So this is pretty standard, but we are also, again, reminding that the game should start with the main module in the main.py file. So this type of stuff you have to do, I found out. But I did say that it needs to carefully reason about the error in a step-by-step manner, and I gave it XML tags within which it can reason, and then after that, it can actually return the corrected file contents. Now I can do that for multiple files, although I should have mentioned that it should, but it does that anyway. And then we also have so this is the system message, but we also have a user message. An error occurred while running the pygame project. Here's the error message. We pass the error message. And now we pass the entire contents of our project. Please analyze the error and provide a corrected version of the files. Resolve the error. Return the full contents of the file. So this was necessary to repeat at several places so that it doesn't redact this final solution, but to just return it. And so we can write it as is. Remember that the game should start with the main module. You can see I repeat this at every possibility. Then we just make the call and we get the corrected files and we just loop over them and rewrite over them essentially. And then we ensure that they were written. And then we clear the Python's module cache. I don't think we need to do this anymore, but I'll just leave it there since this code became quite complex. I don't want to remove anything, but originally I was using a different way of executing the code, which wasn't working very well. Then I switched to sub process. So this was necessary to clear the module cache for that. So it may not be necessary. Maybe I don't know. This may not be necessary. And then we sleep a little just to give system some time to actually make sure the files are written. Otherwise, we print no corrected file content found in the response, just in case if there was such a response, but I never ran into it. Then here's the function to update game files. This is going to gather all existing game files, go over them, and this is it's actually now I'm realizing these function names are not very well written. I'm sorry about that. But this one actually is the feedback agent. You can change them if you choose to download it. This is going to take in the user feedback, and it is again is going to gather all the existing game files and prepare the prompt for the API. And here's the prompt. Here are the current, we pass the entire contents, and then we provide the user feedback, and then we say, please analyze the feedback and suggest updates to the game files to address the user comments. I feel like any one of these system messages can be improved. But anyway, when we do say that please provide the fully updated content, not just redacted versions of them. Return the updated file in this format so we can know which file name plus the contents. Always return the full contents. Game should start with a main module in main.py file with no arguments again. We're also mentioning it here. Now this is the regular prompt, and the system message for this is you're an expert Python pygame developer. Your task is to update the pygame project based on user feedback. You can see that by changing this pygame developer and the mentioning of games here, you can make this accommodate any type of projects. Anyway, so this is the system message for the feedback agent and the call. And then we get the extract the updated file contents from the response, and then we write them. Again, this may not be necessary to clear the cache, but we again sleep and otherwise say no updates were necessary. Here's the function to count the lines of code, looping over all the files just to see how many lines of code we're writing. But like I said, out of all the ones that I worked on, like Space Shooter is nearing about 800 lines of code and Tetris 600. So these kind of projects are not possible with a one-shot generation with just 4,000 token output limits on large language models, at least currently. Now, I do want to mention that these multi-file projects are way harder for large language models. The single script, like a single go at a single file project is actually, it seems large language model will have a much easier time with that, especially considering each one of these files is written by a separate agent, not knowing how the entire project will actually turn out. So keep that in mind. And here in the create game, this is the main function. We take in user input, take in number of iterations, we get the final plan, write it to gameplan.xml. We get the file structure out of that, and then we create a app directory if it doesn't exist, and then we create an async.io list to call the agent write file. These are the agents that are going to be responsible for writing each one of our files. And we async.io gather those tasks, count the lines of code, and then we enter the iterative code execution and iterative correction loop. So in this loop, we're gonna check to see if there are any error messages. If there are no error messages, then we're gonna move on to the feedback correction. So this single loop actually takes care of feedback correction loop with the feedback agent, plus the error correction loop with the error correction agent. So if there are no errors, this part will run and will continually iterate on the code. But even after this, if there's this allows us to, even after a feedback, if there's an error in the code, then we can actually execute that code and try to autocorrect it. Now, if there is an error, we print the error and we try to attempt in max attempt, try to fix it, call the fix game files, count the lines of code, run the game, try running the game again after fixing to see what happens. So this can repeat iteratively. Otherwise, if all the iterations have gone by and we weren't able to fix it, then we print failed to fix all errors after this many attempts. But then user gets a choice to run it one more time. But after that point, the user will have to explicitly agree to run the autocorrection again. And then we just async.run the entire game. So I believe this was This was kind of eye-opening for me. I do want to explore agentic workflows more deeply going into the future. I will be exploring more about function calling as well. I think you will find this very useful. I hope you found the video description of it useful. But if you want to just grab the code files quickly, you can find it at my Patreon. This will be available for architect level patrons. I will be doing more videos on function calling as well and build agentic systems like that. Also, remember that I will be starting regular Ask Me Anything sessions for my patrons, architect level plus patrons. You can find the link in the description. Also, if you want to get in touch with me for one-on-one, you can check out the higher level tiers on my Patreon, on which you can connect with me one-on-one on a monthly basis. Thank you for watching and see you in the next video. I would like to take a moment to talk about the benefits of becoming a patron. As some of you may know, in the last year and a half, I've spent 3,000 hours, over 300 projects as a patron. You will have access to all the code files so you can get inspiration and iterate quickly. Another benefit is that you'll have access to all my courses. And my most recent and most proud one, the 1000x Masterclass, teaching what I've learned on how to code fast and efficiently. Also the Streamlit course and the Fast API course. In my Patreon, I also have tiers in which you can connect with me one-on-one. Check those out as well.